Hello, future engineers, subscribers, students, and viewers. Here is a video about solutions to plane analytic geometry 1. So here we go. For the line joining the points A, quantity negative 3, comma 2, and B, 4, comma negative 3, find the distance AB. Slope of AB, the point of division D closer to B that divides the line segment into the ratio 3:1. Then D, in what ratio does the intersection with D.1 x-axis, D.2 y-axis divide AB? Then find the terminal points if AB is extended 4 times its length. So for part A, we plot point A at negative 3, comma positive 2. That's the position of point A. Then B at 4, comma negative 3. Then we draw this imaginary right triangle. So to make this distance positive, it should be right x. So B4, x of B4 minus x of A, negative 3. 4 minus negative 3 is positive 7. Likewise, the vertical distance between A and B is upper y 2 minus lower y negative 3. So 2 minus negative 3 is 2 plus 3, so 5. So that the distance is square root of 7 square plus 5 square by Pythagoras theorem. So square root of 7 square plus 5 square is square root of 74, or it may be expressed in decimal 8.602 units. The slope of AB. So this is line AB is directed down to the right or up to the left. So for that line, the slope is negative. So from the positive axis to the line, it is clockwise, and clockwise direction is negative. So therefore, this line has a negative slope, and it is rise over run. We just treat it negative. So negative 5 over 7. So negative 5 over 7 is the slope. Then, or negative quantity 5 over 7. Then C, the point of division D closer to B, so which is this, that divides the line segment into the ratio 3:1. So point D divides the line AB into 3:1. So this is 3 parts represented by that green number, and D to be 1 part. So all in all, there will be 4 parts. So that means the ratio of line AD, length of line AD to the length of AB is 3 as to 4 parts, or 3/4, where 4 is 3 plus 1. So ratio of AD to AB is 3 as to 4, 3/4. Now, the ratio of line segment, length of line segment AD to length of line segment AB is also the ratio of their corresponding horizontal and vertical projections, vertical horizontal projections. So this horizontal distance between A and D, to make it positive, is right x, which is xd, minus left x, which is negative 3. So xd minus negative 3 is xd plus 3, while the vertical distance of between A and D is upper y, which is x, which is y of A, 2 minus lower y, yd. So 2 minus yd. Substitute 3/4. So that's also the ratio of xd plus 3 as to 7, because the horizontal projection of AB is 7. So this is xd plus 3. It is only 3/4 of 7. So that's why xd plus 3 as to 7, that would be 3/4. Or xd plus 3 is 3/4 of 7. So solving for xd, xd is 9 over 4. Then likewise, 2 minus yd as to 5 parts, that's also 3/4. So 2 minus yd over 5, where 5 is this vertical leg, is 3/4. Solving for YD, it is negative 7 over 4. Therefore, point of division D is at 9 over 4 comma negative 7 over 4. Another way is, since there are 4 parts, the midpoint can be easily located, and the midpoint of line AB and point B is point D, because the midpoint divides the line segment into two equal parts. Likewise, point D will divide MB into two equal parts also. So the location of M is at uh, 1/2 because the midpoint formula is 1/2 of quantity negative 3 plus 4. 1/2 of quantity negative 3 plus 4 is 1/2. And 1/2 of quantity 2 plus negative 3, 2 plus negative 3, negative 1 over 2, so negative 1/2. So next is midpoint of M and B, which is point D. So XD is 1/2 of 1/2, quantity 1/2, because XM is 1/2. 1/2 of quantity 1/2 plus X of B, which is 4, and that is 9 over 4, which is same as that. YD, on the other hand, is 1/2 of quantity negative 1/2 plus negative 3, and that is negative 7 over 4. Then D.1, in what ratio does the intersection with the x-axis, in what ratio does the intersection with the x-axis divide AB? So this is the x-axis. The coordinates of x of that point of intersection is x-intercept a comma 0. Since this vertical distance is 2, y-coordinate of a, and this horizontal distance is 3, and horizontal distance from the y-axis to B is 4. Vertical distance of point A from the x-axis is 2, that y of A there, and the vertical distance of point B from the x-axis is 3, that negative 3 there. Just make it positive because we're referring to length of this triangle. Therefore, AX, this is X, as to XB is equal to ratio of their corresponding vertical projection. So which is 2 and as to 3. There's no need to apply uh, like here. We just simply consider the equal parts because this angle and that angle equal. So AX as to XB is 2 parts as to 3. Likewise, in the point 2, the y-axis, this is the intersection, that's point Y, and the coordinates should be x is 0, y is y-intercept. Because from the x-axis to point A, that's 3 units, represented by that negative 3 there. And from the y-axis to point B, that's 4 units. So the ratio of AX, AY to YB is equal to ratio of corresponding horizontal projections, 3 as to 4. So you have 3 as to 4. Letter E, find the terminal points if AB is extended 4 times its length. So take note, there are two possibilities. This may be the external point extended in that direction. In this direction, we'll call the terminal point B sub D. So this is the best way to analyze it, because we extend the length of AB 4 times its length, then the horizontal as well as the vertical projection should also be extended or multiplied by 4. So for instance, this is 7. So we extend, that's the long break, of course, the when we multiply 4 times, it will be there. It may be outside the screen. So just have that long break. So this is 4 times 7, where 7 is the horizontal projection of AB. While this is 4 times 5, where 5 is the vertical projection of AB. So from there, we can analyze x80 and y80. And we extend also B to this terminal point here, B sub D. So this is 4 times horizontal projection of AB, 4 times 7, and the vertical projection, this one is 4 times 5. So therefore, x A sub D is equal to negative 3, beginning at negative 3, because this is to the left direction. Negative 3 minus 4 times 7 is equal to negative 31. Then y80 in the upward direction, so we begin with 2, ya 2, then plus 4 times 5, 2 plus 4 times 5, y80 is 22. Therefore, the terminal point when extended in that direction is a sub t quantity negative 31 over 22, while the terminal point of b in this direction, so we have x bt 4, then going to the right, so 4 plus 4 times 7 is 32, while y sub bt is negative 3, and because this is in the downward direction, negative 3 minus 4 times 5 is negative 23. So the terminal point B sub t is at 32 comma negative 23. Problem 2, find the angle from which the line segment joining the points 2 comma negative 1 and negative 3 comma 4 makes with the positive x-axis. So this is 2 comma negative 1, and that is negative 3 comma 4, and we are looking for this angle from the positive axis to that line there. So we can analyze for this acute angle here. Again, we compute the parts of this right triangle, the horizontal and the vertical legs. For the horizontal leg, to make it positive, it should be right x, which is 2, minus left x, negative 3. 2 minus negative 3 is 5. For the vertical leg, to make it positive, upper y 4, minus negative 1. So that's 5. So since the parts of this right triangle are equal, 5 and 5, we know that this is 45 degrees, or inverse tangent of 5 over 5, 45 degrees. Therefore, theta is equal to 180 degrees, a straight angle, minus 45 degrees, so 135 degrees. Problem 3, a line passes through point A at negative 8 comma negative 1 and B at 4 comma 3. Find the coordinates of the point on the line whose distance from point A is 3 times that of B. So this is the point such that the distance of this point from point A is 3 times its distance from point B. So if we call the distance of this point P here to be as d sub B, then the distance of point P from A is 3 times d sub B. So again, it's like we divide the line segments into 4 parts. This is 3 parts, and that's 1 part. So we have to obtain these projections because 3 dB as to length of AB, which is 4 dB, so that's 3/4 again. So it is equal to 3/4 is equal to the ratio of the horizontal projection of A to P and this horizontal projection here. So let's solve first for the horizontal and vertical projections of the line AB. For the horizontal projection, right x 4 minus left x negative 8, so that's 12. For vertical projection, that's upper y 3 minus lower y negative 1. For 3 minus negative 1, positive 4. So therefore, if we call this point P x comma y, this is upper y minus lower y, negative 1. Y minus negative 1 is y plus 1. For this horizontal projection, it is right x minus left x negative 8. X minus negative 8 is x plus 8. So this is the second solution. The first solution, because the line AB is like divided into 4 parts, then we locate the midpoint first, M, then the midpoint of M and B is this point P here. So because there are 4 parts, we have even number of parts. So let's solve for M first. Our formula is 1/2 quantity negative 8 plus 4, and that's negative 2. Ym is 1/2 quantity negative 1 plus 3, that's 1. So P, x is again midpoint between M and B. So x is 1/2 of xm, 1/2 of xm, which is negative 2, plus b, xb, which is 4, and that is 1. Y is equal to 1/2 of ym is 1, and yb is 3. So 1/2 of quantity 1 plus 3, it's 2. Therefore, the point P, or the point, coordinates of the point, which is 3 times uh, the distance from B. So its distance from A is 3 times that of B, is at 1, 2. So the other solution is this x plus 8 here, horizontal projection of AP, is 3/4 of 12, or the ratio of x plus 8 and 12 is 3/4. So AP over AB is 3/4. So x plus 8 over 12 is 3/4. Solving for x is 1. Then the ratio of y plus 1 and 4 is also 3/4. So y plus 1 over 4 equals 3/4. Solving for y is positive 2. So the point P is at 1, 2. Problem 4, the line segment drawn from point P x, 3 to 4, 1 is perpendicular to the segment drawn from negative 5, negative 6 to 4, 1. So we have 4, 1, negative 5, negative 6, so that this line is perpendicular to that line. Probable position of x, 3 would be here. So this is x, positive 3, 4, 1. So since for perpendicular lines, the product of their slopes is negative 1. I hope you can remember that. So slope is delta y over delta x. So 1 minus negative 6, so 1 plus 6. Then delta x, 4 minus negative 5, that's 4 plus 5 for slope of line 1. So this is the guide. Product of slopes for perpendicular lines is negative 1. Then for this line 2 here, the slope is 3 minus 1 over quantity x minus 4. So 3 minus 1 over quantity x minus 4. This is 7 over 9, and this is 2 over x minus 4 equals negative 1. So that means divide everything by negative 1, or cross multiply, then negative 1 in the denominator in the left. So 14 over 9 negative is negative 14 over 9. Then x minus 1 times positive 1, because we divide everything by negative 1. So it is x minus 4. Solving for x, negative 14 over 9 plus 4, 22 over 9. Problem 5, determine the acute angle between the line segment drawn through negative 3, negative 3, negative 4, and 5, 2. So problem 9, find the equation of the set of all points equally distant from the y-axis and 4, 0. So this is 4, 0, and this is the possible locus of the point, which moves so that it is always it is always equidistant from the y-axis and from this point here. So I'll call that d sub 1 and this one d sub 2. D sub 1 is actually the distance of the point from the y-axis, so that is equal to x. So d sub 1 is just x. While d sub 2 is distance between 2 points, that by Pythagoras theorem, square root of quantity x minus 4 square plus y, quantity y minus 0 square. So distance 1 equals distance 2. Again, distance 1 is just x, and distance 2 is distance between 2 points, square root of quantity x minus 4 quantity square plus y minus 0 quantity square. Square both sides, so x square equals quantity x minus 4 square plus y square. Expand the right side, so x square equals x square minus 8x plus 16, then plus y square. Cancel out x square, simplify. The answer is y square minus 8x plus 16 equals 0. Problem 10, what is the locus of a point which is at a distance of 4 units length from 5 comma negative 2? So this is the point 5 comma negative 2. That's the moving point. And as it moves, its distance from 5 comma 2 is maintained at 4. So therefore, the locus is a circle. That is a parabola. And you will learn that later when we, or in future videos when I discuss parabolas. So distance between 2 points, Pythagoras theorem, x minus 5 quantity square plus y minus negative 2 quantity square equals 4 square. So quantity x minus 5 square plus y minus negative 2 is y plus 2 quantity square equals 4 square by Pythagoras theorem. Expanding, x square minus 10x plus 25 plus y square plus 4y plus 4 equals 16. Simplifying, we have x square plus y square, which is a circle, negative 10x, then plus 4y, 25 plus 4, 29 minus 16 is 13. So x squared plus y squared minus 10x plus 4y plus 13 equals 0. 11. Find the locus of the center of the moving circle tangent to the y-axis and to a circle of radius 2 with center at 8 comma 2. So this is the center of this circle with radius 2, 8 comma 2. And we have to draw sets of circles that will be tangent to this circle here and to the y-axis. So these are just sample of circles. So at the center of this moving circle, we denote the coordinates with x comma y. And since the distance of that point from tangent to the y-axis, so this is horizontal, the radius of that varying moving circle is x, the radius is just x, the distance of the point from the y-axis is x. And therefore, this is also x, the radius of the circle, and that is fixed at 2. Then we have a right triangle here. The horizontal projection is x minus 8 or 8 minus x, it doesn't matter. Then y minus 2 for the vertical, or 2 minus y, it doesn't matter also because we apply Pythagoras theorem again in this right triangle. So from the figure, x minus 8 quantity square plus quantity y minus 2 square equals the hypotenuse x plus 2 quantity square. Expanding, x square minus 16x plus 64 plus y square minus 4y plus 4 equals x squared plus 4x plus 4. We cancel out x squared and this 4 here, simplifying y squared minus 16x minus 4x, so negative 16x minus 4x is negative 20x, then minus 4y, 64 plus 64 equals 0. So that's a parabola. Actually, that is also a parabola open to the right. Parabola open to the right. Problem 12. Find the equation of the line through negative 3 comma 4. Then letter A parallel to, letter B perpendicular to 3x plus 7y minus 8 equals 0. So we apply shortcut way here. Solution for part A, if the line is parallel to this line here, then the line which is parallel to this line will have the same first two terms in x and y. So 3x plus y equals 3x1 plus 7y1. That's the shortcut. Instead of knowing that they have the same slope, they have the same slope. This one has also slope of negative 3 over 7. So that's why we equate it to 3x1 plus 7y1, where x1 and y1 would be coordinates of the point where this line passes through. So 3x plus 7y equals 3 times negative 3 plus 7 times 4. So the answer is 3x plus 7y equals negative 9 plus 28 is 19. For perpendicular lines, remember the technique, you have to interchange coefficients and change the sign between them. So we have 7x, then minus 3y equals 7 times x1, 7 times negative 3, then minus 3y1 minus 3 times 4. So simplifying, 7x minus 3y equals negative 33. Problem 14, find the angle between the lines 3x plus 4y equals 0 and 5x minus 2y equals 3. So solution, 3x plus 4y equals 0. The slope is negative coefficient of x, which is negative of 3 divided by coefficient of y 4, negative 3/4. So that means it is sloping down to the right, and its angle from the positive x-axis is clockwise. Then 5x minus 2y minus 3 equals 0. The slope is negative of 5 divided by negative 2, so that's positive 5/2. So it is inclined up to the right. So without memorizing the formula, this is the formula, then we can determine the acute angle between the two lines. So it should be the acute angle if not specified. So this is line 2 and this is line 1. The angle here is negative inverse tangent of 3/4, while the angle here is inverse tangent of 5/2. 3/4 is the slope of line 1 and 5/2 the slope of line 2. Remember that uh, the angle that any line makes with the horizontal positive x-axis is equal to the inverse tangent of the slope. And if the answer is negative, it means it's clockwise. This is anticipated clockwise because the slope is negative 3/4. That's why I just make it positive but in clockwise direction. So inverse tangent of 3/4 is 36.87 degrees, while inverse tangent of 5/2 is 68.2 degrees. If we add these two angles, that's more than 90 degrees. So therefore, this is the acute angle counterpart, and that theta there is 180 degrees minus 68.2 degrees minus 36.87 degrees. So it is 74.93 degrees. If you use the formula, tangent theta equals slope of terminal line minus slope of initial line over 1 plus slope of terminal line, slope of initial line. Remember that this is from tangent of theta 2 minus theta 1, that's the expansion. Tangent theta 2 minus tangent theta 1, tangent theta 2 slope of terminal line, or tangent theta t, minus slope of initial line over 1 minus 1 plus slope of terminal line, slope of initial line. So substitute, because in counterclockwise direction, this should be the initial line and this should be the terminal line. Even if we use this angle, they are equal to that theta. This should be the initial line in counterclockwise direction, and this should be the terminal line. So that's why I'll call this LT, and that is L sub I. The slope of Li is 5/2, slope of Lt is negative 3/4. So 5/2 minus negative 3/4 over 1 plus 5/2 times negative 3/4. Tangent theta is negative 26 over 7. But the calculator cannot detect that it is this acute angle. We are just given that it is negative. So it means that when you use your calculator, it will give us a negative value also because it is treated uh, clockwise. So negative 74.93 degrees, but we'll make that positive 74.93 degrees. 17. Find the equation of a line that bisects the acute angle between lines x minus y minus 1 equals 0 and 7x plus y minus 7 equals 0. So remember, distance from a point to a line is we put plus minus in the numerator, then ax1 plus by1 plus c all over plus minus in the radical denominator, square root of a squared plus b squared. The sign in the numerator is positive if the point lies above the line. The sign of the radical is the same sign as that of b. So if I call this r1 and that is r2, same as that distance there, r1 and r2 are perpendicular distances from these lines respectively. So r1, this is line 7x plus y minus 7 equals 0. That is treated positive because this point, which is denoted by x comma y, is above this line. Now, we have positive because this point is above that line. Quantity 7x1 because the point is x comma y, x1 is just x, plus 1y1, so plus y, then minus 7 all over because the coefficient of y is positive 1, so the sign of the radical is positive. Square root of a square, 7 square plus 1 square equals, this point lies above this line here, so it's again positive. Quantity x1, which is just 1x1, which is just x, minus y1, so which is just y, y1 is just y, then minus 1, you just copy over negative because the coefficient of b, negative 1, the coefficient b is negative 1, so negative also square root of 1 square plus 1 square. Simplifying, 7x plus y minus 7 over square root of 50 is 5 square root of 2 equals x minus y minus 1 over negative square root of 2. So cross multiply, 7x plus y minus 7 equals, this is 5x over negative 1, so negative 5x, then negative 5y over negative 1, positive 5y. 5 times negative 1, negative 5 over negative is positive 5. Simplifying, 7x plus 5x, 12x, y minus 5y, negative 4y, 5 plus 7, 12, divisible by 4, divide everything by 4, 3x minus y equals 3. Now for the technique, the point, this point is at 1 comma 0 because when we sketch this graph, we can assign, for instance, when y is 0, when y is 0, 7x equals 7, so x is 1, 1 comma 0. Then this one, when y is 0, x is 1, right? Then when x is 0, y is negative 1. That's why this is the graph of x minus y minus 1 equals 0. Earlier, when y is 0, x is 1, and when x is 0, y is positive 7 there. So that's why we connect them with straight line. So that's the answer. Then, if it is a problem in the board exam, this is a bit challenging because there may be, you cannot remember this distance formula between a point and a line. Now, the technique is find the point of intersection, and the equation should be satisfied by this point of intersection between the two lines. Like if this is the answer, 3x minus y equals 3. Remember that this is 1 comma 0. 3 times 1, 3 minus 0 is 3. So that's why 3 equals 3. So that's the technique. Then 20, the equations of the sides of a square are quantity 3x plus 4y minus 15 equals 0 and 3x plus 4y plus 5 equals 0. What is the area of the square? So notice that these two lines are parallel, therefore the side of the square is the distance between parallel lines. For distance between parallel lines, remember in the principle and explanation formulas, which can be derived also, absolute value of the difference of constants divided by square root of a square plus b square. So distance or side of square, so area sa square is distance square or side square. It is equal to c sub 1, negative 15 minus c sub 2, so minus 5 all over square root of a square 3 square plus b square 4 square. So that's why it is 20 over 5 is 4. Distance equals 4 units. So area equals 4 square. Area equals 16 square units. So that's it for this part 1 of the solution to sample problems in plane analytic geometry 1.